Hi everyone, welcome. Welcome to our MOOC this evening. Today's MOOC is Data for Good with Experian EMEA. So backstage of me, Aileen, I am a Code for Skills brand ambassador. So if you have any questions about Code for Skills or other upcoming classes, please put them in the YouTube chat and I'll get back to you. I'm currently a delivery manager in FinTech. So I'm really excited to be working with Code for Skills, whom I've known for quite a number of years now. So backstage, we have a great Experian team lined up for you. We have Paul, Head of Innovation for Africa, Giulio, the Senior Data Scientist for Italy, and we have Leandro, an Analytics Consultant for the EMEA region. So I'm going to add them to the stream so you can have a look and say hello to them. Hi, Paul. Hi, Giulio. Hi, Leandro. Good to see you. So yeah, really excited to have you guys joining us tonight. And Paul, I'll hand over to you to start, to kick us off.
Okay, thanks. Yep. Good evening, everyone. Good afternoon, everyone, or good morning, everyone, depending where you are across the world. Just confirming that you can all hear me okay? It's all good? Yeah. So it's a great privilege to be able to be here with all of you today, although it's all this virtual world, we're all accustomed to it. And it's a very exciting moment for myself with Giulio and Leandro to be able to talk to all of you. So we're going to talk to you today about Experian and doing data for good and powering opportunities. And it's my pleasure to be able to introduce to you who Experian is and what data for good actually means for us. Just to give you a background is I run the innovation portfolio for Experian on the African continent, which in my mind is a very exciting place to be with very exciting challenges. And at the end of the day, most of the opportunities that we have to solve and sort out rely on data and our interpretation of data and the usage of that data to really get into building insights. And that's what we're going to talk about. So if we just go to the first slide, we're going to talk to you today about who Experian is and what do we do. Now, I know when I introduce Experian to a lot of the people I know, people I don't know, not everyone is actually aware of the organization. Even more so in Africa, because our credit scores, which Experian is a global leader in calculating, is not something which is culturally understood and well known by everybody. So when we say that we are a credit bureau, it normally leaves a lot of surprised looks and feels back in response to us. And so I want to alleviate some of the concerns that people have about it and really show you that we are more than a credit bureau. We actually are a data to insights company, and we want to build data for good. So if you just go to the next slide, and what does it actually mean for us as an organization is that we unlock the power of data. And we all know what data is, we all talk about it, but we don't actually understand what we can actually do with it. And that's the most exciting part that keeps, that gets Giulio, Leandro, and myself going to work every single day. And the power of the data really comes from the following. If you just go to the next slide, sorry. Is that we make sense of it. One of the things, you can have a look at data, you can open Excel spreadsheets, you can open code and all these sort of good things, and it's just a whole bunch of stuff, as I like to say. But that stuff really, when engineered properly, understood properly, taking the sense of understanding of what consumers and businesses and corporates are looking for, societies and communities, we can start merging that and modeling that into making something that tells a very fascinating story and that radically can change lives and make an impact on everything that we do. And that's what we firmly believe in. Because we are on a mission as an organization to deliver this full power of data, analytics, and technology in a way that transforms everyone's lives, but most importantly, for good. And I think that's the thing that drives us very strongly, and that's the things that we fundamentally believe in as an organization. Next slide. But when we talk about Experian, I want to just position something for you. So when Giulio and Leandro go deeper into the work that we're going to showcase to you now, which is all very exciting, you also need to take a big step and have a look back who we actually are. We are a truly global organization spread across all those countries that you can see. I think we operate in 44 countries with an excess of 17,800 employees. So large business, large scale. But the data that we have is even more mind-boggling and encouraging to see that when we talk about these things, we're not talking about perhaps Mickey Mouse, we're actually talking about Disneyland. Because we have credit data on 1.3 billion consumers. That's billion with a B, not million. 1.3 billion consumers. We have data relating to 163 million businesses across the world. We use that data, build scorecards, build insights with a 99.9% accuracy rate. And we serve over 100,000 corporate clients across multiple sectors in all the geographies that we operate in. So when we talk about data, we're talking about data at scale. And when we're talking about doing good with data, we're talking about doing good with data at scale. And this is the things that we fundamentally believe in. We don't do things traditionally. We do things in a very creative and innovative way. So I'm very blessed to share the screen with Julia and Leandro, because these two guys really know and really create different mindsets and elements to really challenge ourselves on. And we step up as an organization to get stuck into that. So like I said before, we are here to change the world for good. We're going to do that by unlocking the power of data. And we can do it in a way which is not a traditional business way, because we understand the human being. Because we understand, and we have gone through the same frustrations that you have, is that we aren't looking for credit scores. We're looking to buy a house, to buy a car, to get access to a loan, to educate our children, to be able to go on holidays, to experience life to the fullest. And sometimes people don't understand that. People don't understand how it works and how it doesn't work and why is it a struggle. And we as Experian fundamentally believe it's our job to change it. So our Chief Financial Officer, Lloyd, our Chief Financial Officer, Lloyd, says that it's important for us to make sure that everybody is included and has access to fair and affordable financial products. Let me highlight again. We want to make sure that everybody is included. Now, in Africa, financial inclusion is one of the things that we drive fundamentally. We believe in social impact. We believe in making a difference for everybody, and we have to make a difference. And it's fundamental to our business. It's crucial that we do this with not only just a corporate mentality, but with a social heart mentality as well. And also important to believe that we want to increase access to financial products by improving the financial literacy and confidence of people. So if you don't understand something, we want to help you understand that. We want to help you on a journey to understand things and grow better, because we believe in people, we believe in businesses, and we're here to help empower them and build and scale for the future, create a better place for us using the power of data. So that's a very brief introduction. If you just go on to the next slide, there are some social media places where we can take coverage and all this sort of things. But I'm going to hand over now to Julia, who's going to show us something which is not what you'd find anywhere else in the normal realm. So Julia, over to you.
Thank you very much, Paul, and thank you for the opportunity today to be here and to really share my experience with Experian, what we are doing. So I would like just to say a couple of words about my personal story with Experian. I joined Experian now 5 years ago. I was coming from the University of Physics in Florence, so very far from a traditional business and economics context, more focused on mathematics, AI, and of course technical background, I would say. My real passion was to apply all the math that I was studying into something very concrete. And now I would like just to introduce you to how really you can apply this kind of methodology, maths and background into something very tangible. Because as Paul said, our real aim is to use this data to help people, to help business, to really use the data in their daily life. So if you please can go to the next slide. Yes, I would like just to introduce you to what is artificial intelligence and what is machine learning. I am absolutely sure that every one of you has heard about AI and machine learning. Now this is a very common word that we are used to use for a lot of context. And the reason is that artificial intelligence and machine learning actually is something that comes from quite a lot of time. We will see a little bit of history, but today that's really changing and revolutionary the world. And I would like just to start with you with the next slide. please, and we will try to deep dive with a video about what is AI and machine learning and why it's so famous today. So if you please can launch the video, it really will last 30 seconds and you can see what's the power of AI and machine learning today. So I think just you saw something that probably every one of you has already heard so far. So basically AI and artificial intelligence today can do a lot of stuff that is involving the financial industry, but it's going into the direction also of self-driving car, security systems. So it really is changing the way that we use digital channel for any kind of business in the world. But what's the background about AI? So where this is coming from? Actually, the first time that someone used the word artificial intelligence, this was really an old concept coming from the 50s. And actually, this was coming from CIA that was referring to a group, a very limited group of so-called geek. So people from university with a background in, maths, physics, informatics, and they were trying to automatize some processes. And they were doing with computer that at that time was something, of course, very far from what a personal computer are today, but still the concept was very clear. So automation of some instructions. And actually that concept started in 50s and it continued for around 30 years. So with some very easy if-else condition, you can automatize a lot of processes and make it be automatic and more efficient. But then in the 80s, something new came up. And it was the concept of the so-called machine learning. So what's the difference between AI and machine learning? Well, AI in general is everything that is referring to any kind of an automation. Machine learning is a step beyond, and basically it's not just about any kind of automation, but it's automation through some particular algorithm. Now, algorithm means just rules, and rules can be easy with some easy conditions or can be very complex. Well, between 1980s and the first decades of the 21st century, a lot of new algorithms grown up. And we started with very basic regression and we arrived until very complex models. So from gradient boosting to random forest to extreme gradient boosting. So a lot of algorithm that was automatizing a lot of processes. And finally, that reached out to the final step. So in the last 10 years, there were two main revolutions. On one hand, we had the opportunity to use much more computing power, and this was due mainly to the cloud migration. And basically, cloud today is allowing us to use big data, so very large volume, but also big computing power. So you can use lots of data in a very quick and efficient way. And to make it in the best way, you can use artificial intelligence with machine learning algorithm, and in particular with the so-called deep learning algorithm that definitely are the ones that are overperforming in terms of accuracy of the model with neural networks that probably the most of you have heard about. So this kind of algorithm really are super accurate, but also super efficient and super quick. And today we are using this in order to train model. So if we please go to the next slide, I would like just to, again, start with what is really a machine learning model. Well, as said, Basically, a model is just a function that takes some data, so inputs, and change according to some parameters. And given this, it gives back a prediction. So as Experian, we are using this in a number of use cases. So for example, we are using credit data to predict default, to prevent credit risk for banks. But also, for example, we are using temperature and other geographical data to predict what will be the behavior of global warming in the next 5 and 10 years. And this is very important for environmental, social, and governance legislation, and how we are contributing with data for goods to help people reducing pollution across the globe. But at the same time, we are also using this kind of models to contribute to financial inclusion. So for example, we are helping young companies and startups using web data to get access to new credit, to help their business and to realize young people's dreams, to make it be reality. So as you see, potential very complex mathematics is becoming something very tangible and clear, because it's all about this very easy formula. We are taking algorithm F, we are using data X, we are driving this according to parameters, and we are predicting something. And please, if we go to the next slide, we can see the number of types of machine learning and deep learning. So you see here a jungle of different algorithms that you can use. There are 4 main possibilities: so-called supervised learning, unsupervised learning, semi-supervised learning, and the cutting-edge technology called reinforcement learning. Well, you see, there are really a number of potential algorithms. And, when I joined the company 5 years ago, I perfectly remind that we were starting to speak about AI and machine learning together with Leandro, Paul. And basically, a lot of people were looking at us saying, but what's that? How does it work? Is it reality? Or is it something for geeks like you, people with, that loves mathematics, but very far from the business? So they really couldn't get what it was. And especially, I do remind something that I was used to hear nearly every day. And most of people was saying that AI, machine learning, was a black box that was digesting any kind of data and giving back answers without any kind of justification. So if we please can go to the next slide, I would like just to reinforce one key message that I think it's probably the hottest topic about AI and machine learning. That is the so-called machine learning explainability and interpretability. So, as said, in the last 5 years, we spent a lot of time in technology and data for goods. And to be something very concrete and pragmatic for the daily life of people, we need also to justify this. So today we are fully able to take any kind of machine learning models, from regression to gradient boosting, to random forest, to neural networks, to reinforcement learning models, and we can fully justify why we are taking that decision. So we are avoiding any kind of black box. It's all fully justifiable. And this is something that really required a lot of effort, actually. But today we're very happy that we can say why you can accept or reject a request for a loan, why some kind of information are relevant to take a certain decision, even if you're using a really complex model. And as said, it's possible to justify decisions, it's possible to control data. So we have the full access to all the data that are contributing. But what is mostly important is that we are improving and discovering new way to take data and use it for automatizing better decision. So we are improving the accuracy of the model, but we are also discovering a new way to include more people to credit access. So we are really trying to help businesses and people to have a better life through AI and machine learning. So really, I want to thank you again to give us the possibility today to present this. And now I would like to hand over into Leandro that can show you a practical example of how we code it and how we make it. Thank you.
Julio, good afternoon whenever you watching us. So I am
Leandro, your audio is a little bit robot-y. Is there any way we can try and change that?
it's the connection is not so good.
No, it's still no. It still sounds about still sounds about the same. Is it? Just use the microphone.
Let me just something else.
Yeah, that's fine. In the meantime, does anyone in the audience have any questions? Oh, Leandro, do you want to try again?
Yes, is it any better now?
Yes, so much better. Now we can hear you.
Yeah, apologies for that. Perfect.
Okay.
So,
all right, carry on.
Okay. No, thank you. I was just introducing myself. So nice to meet you all. Leandro Guerra. I'm currently the head of data science and analytical platforms for Experian. I have been in the company already for 10 years. And actually, I am Brazilian. I have worked 4 years for Experian in Brazil, and currently I am already 6 years now in Experian in EMEA, responsible for the EMEA region. And what I'm going to share with you today, that we could get through some bits of coding, actually, that are just amazing to do and to show exactly what we can do in reality. So please, if there is any confirmation that you can see my screen, I would appreciate that. So we can be okay to. Yep, beautiful.
Yeah,
so I mean, unfortunately, fortunately, I could stay the whole day talking about coding. However, given that we have limited time today, I would like you to please pay attention to some very specific components about coding that I would like to highlight. We were talking with Aileen. We are going to be able to make this code piece available for you. I have used a public data set, so you're going to be able to study it and to reproduce, to learn exactly what has been done. When we talk about coding, and here I'm using Python, the first thing that I would like to highlight is one. You may be in the beginning of your journey and you might be concerned that, well, should I start Python? Should I start R? Should I start Julia or whatever other language? Please have in mind that programming languages, they are only tools. So the preferred option is that learn Python, learn R, learn as many as languages as possible, because they are going to be part of your toolbox. And whenever you have something to solve that it's actually a business problem, you are going then to be able to pick up and to choose the best tool out of your toolbox. So this is the first point that I would like to highlight. I like to say that because in the beginning of our careers, we always get confused, or we start arguing that some language is better. It's better than the other. And then, of course, all of us, we do have our personal preferences. So I will be coding here in Python, but my personal preference is R. but I'm doing exactly this like that just to show you that programming languages, they are just tool. And whenever you are doing that, we do this for two main reasons. The first point that I would like to highlight, and we are going to be running today, choose a database regarding credit card approval. So we are going to build a logistic regression model that is actually the most used algorithm in the industry as today, as I am speaking. There are trends around gradient boosting algorithms to be replacing them maybe in the future, but yet, I mean, the vast majority of models, they are built under logistic regressions. And this is another point very, very important to say. I mean, if you are in the beginning, you see that forest of models that Julio shared with us previously. There are so many to learn, and usually we don't know which one or from where we should start. So I recommend you to actually get 4 kind of models with a very good understanding from the very beginning. So linear regressions, logistic regressions, decision trees, k-means, and neural networks, exactly in that order if it's possible. So if you have domain around those 4 main algorithms for predictive modeling, you're going to be able to solve at least 80% of all problems that they are out there. Of course, it has a relationship, a directly correlation with the industry that you're going to work with. So if you're going to build self-driving cars, very likely you are going to be developing deep learning models. But even to get a very good understanding what a deep learning model does, you need to get always to the basis. So I would have this as a suggestion as well. And whenever you're going to build a model, we have a flow that we need to have in mind. So you can be the best programmer in the world. However, if you don't understand the business that you are in, and if you don't understand the data that you have, well, I'm not sure if being the best programmer in the world is going to solve that much. So you really need to understand which business are you in and which data it's available for you. This it's quite important because this is what you need to go through a nice step that it's called the data preparation. And the data preparation means that you're going to look at the problem that you have to solve, that you have to address with your coding skills, with your analytical skills, and be able to transform that data into valuable information that are going to be the inputs of your model. So again, we have that big amount of model techniques to follow. But sometimes your model is going to be just as good as your data. And your data is just as good as your data understanding that is just as good as your business understanding. Do you know my point? Do you know what I mean? So, and those steps, they comes prior to the modeling component. That's why I emphasize this. And then you go to the end, that is the evaluation. Eventually, you may have to get some steps back to understand the business again if the model does not come out that good. And then you go finally to the implementation. And specifically talking about the Experian business, we have the models utilized for what we call the customer life cycle. So from the very beginning, when a company is yet prospecting what a good customer would look like, until the very end, if eventually that customer already left the business, or if they, I mean, unfortunately, they went through a collection stage, we can build machine learning models for whatever step of that customer life cycle. So particularly speaking on the coding that we are going to be having today, I'm going to be concentrating here into the origination phase. There is the phase that we are going to build the model to accept or not the request for a credit card approval. So when using Python, and more than the code itself, given that we don't have that much time for the full code, please follow some very important stuff. Your code would be read not just by yourself, but for other colleagues. So try to comment your code as much as possible. So, and I have a particular way, every programmer, they have their own particular way. What it's important is that you follow at least some standards that other people can understand what you did, especially when you work in a collaborative environment. So here I'm going to be using some of the traditional libraries from Python as pandas, NumPy, sklearn, and stat models. So I'm going to be bringing them over here. And then I will be loading the database. It's always recommended that you do some initial checks into your database, of course, because you need to understand what you have. So you can see from here that, well, the database itself, it doesn't tells me anything when I take a look, but at least I know that it has been loaded quite well. I understand that, I have almost 700 registers and 16 attributes, with one of them being the target, if the credit card application has been accepted or if the application has been rejected. And then I can take a look into the types of the attributes that I have here. This is quite important because some of the models, they may work better if you have categorical data or non-categorical data. Some of them, they just work with numerical data. So you need to pay attention what you have in. And there are several things that you can do in order to transform that data in a better way. Now, the second thing that always it's interesting to have, it's to check for missing values. So if you are a little bit advanced in programming or in doing machine learning models, you, well, might be quite familiar with that. Now, there is one tricky point. So if I go to a traditional piece of code from Python, where I use the methods value and any to really understand if there is any kind of missing value in my data, I would get a false response. So meaning that, well, I don't have any missing data to worry about, which it's not true. And that's why I have printed the data in the beginning. So if we really pay attention to what we have in the data, you can see that some of them, they are not necessarily being classified as, not present or missing, but they have a question mark. So the missing data, it's a question mark. So you need to be careful whenever you try to trust some of the methods of whatever the language to understand what you're doing, because some of the components might be hidden in the data. So you need to really describe, get a deep understanding on what you have. And then once you are done, it's quite easy. So you just use a method to replace the data, and I will be replacing the question marks by to not a number. And then I'm going to see that eventually that record, now it's not a number. So I'm fine by now with the missing values. So if I will recheck again the missing values, well, voila, now it's true. And previously it was false. Those things, they may sound simple, but if you don't get the attention from the very beginning on these components, very late in your coding, you're going to have headaches. Something is not going to work, and then eventually you don't know why. And sometimes the reason, it's going to be quite simple as that, and the solution as simple as that. There are also several techniques so that you can use in order to replace NAs, like you can replace the missing values, of course, by the average. You can replace the missing values by, for example, the most common value. You can even build predictive models to replace the missing values. You can get the nearest neighbor to replace the missing values. So there are several techniques. I'm just filling up them in with the main value that we have over here. Now, the point is, when we look also at the attributes, we can see that especially variable number 13, it looks like a postal code. Now, there are some kind of information that there might get your model biased. And the bias in the model, they can be bad. You remember Giulio talking about the explainability and the interpretability of your model. We do care about it. We cannot have models that are going to discriminate something or get biased by something that we cannot control. And then eventually, well, naturally, if you are on wealth neighborhoods, well, very likely they will have more money. They are more likely eventually to be accepted. which not necessarily is true, because I also have good payers in other neighborhoods that they might not be so wealthy. So eventually you have to remove, or you have to find a way to handle this kind of bias. In my case, that is quite simple. I would just drop it, that is specific variable, and that will be it. Then, just for my understanding, I don't like and I don't recommend that you get the numbers, since we don't have the full name of the variables. I'm going just to rename them for var1 and so on until my target, and then we can have something that it's a little bit easier to read. Now, what we can see is the following. Some of the attributes that we have, of the variables that we have, we can see that they are categoric. And then, well, eventually you need to work with them and convert them to something else. So what you can do in order to transform your variables, your attributes, that they are categoric to something that it's a numeric. So you can apply a model like the logistic regression, for example. And remember that in the very beginning of the code, again, I did a check and I could see by the type that several of my attributes, they are not numeric, they are objects. So I need to find a way to handle them and convert them into something that it's reasonable. So here I use one of the techniques coming from a specific library from Python, that it's the label encoder. And the idea of the label encoder, it's exactly to transform my categorical variables into numerical variables. Now, here again, there is another point of attention, because in several cases, I need to understand if the order of the numbers, and then they are going to really make the difference if they're going to be important. So like, for example, in grades, if I'm grading something like for A, B, C, D, and E, well, having A classified as 5, B as 4, C as 3, and so on, it may be quite different for the model itself. So we need to pay attention on this kind of components as well. It's not just about quickly transforming something by code. You need to understand what you are dealing with. By simplicity, since our variables here, they are just numerical attributes, it's always important to get some visualization of your data, because out of it, you can already have some very good understanding on how to deal with some of your data. So here, using the histogram into my database, since this is everything, it's already numeric, I can quickly understand the distribution, and I can see that I have many variables that eventually they might not be that good, because they are concentrated just in few values, very different from attributes like I have here on variable number 2, that I might have it distributed more interesting along with the full patch. So I will pick up just a variable number 2 as an example. So, and then you're going to see that I have a large distribution of numerical variables associated with my target. Now, sometimes it's good that you create intervals, or you create bins for your variables, so you can get your model to distinguish better some specific zones of your attributes, that eventually they might have a better fit to the model, rather than just the continuous numbers that you have in there. So you can, for example, assign specific variables into bins and rename the bins. So it's like converting your numerical variable into something that it's going to be intervals. And those intervals, eventually the model will be more interested in understand the predictive power of them during the training of the model, and then you can get better results. I mean, not all the time it works like that. Sometimes you don't get better results out of it, but usually it's a very technique, a nice technique, so that you can understand. Now, why I'm saying this? Because if I do like we do in Excel, I do a cross table with my new variable that I have created from the bins of the variable 2, and I do a comparison between the accepted and the rejected applicants, well, I'm going to see that, well, there is a difference. As far as, I mean, as I increase the value of the variable number 2, I can see that I'm actually decreasing the number of accepteds and more or less keeping it stable the number of rejected. So it means that as higher the values of the variable 2, the less I'm going to accept. And now, because I have the bins, my model will be able to capture better this information, and very likely I'm going to have a better predictive power rather than using the variable alone itself. So I'm just do a handling of a possible NAs again, take a look into the database, and then I remove var2 because, well, I already converted into something else, and now I have to actually, not that I have to eliminate the other one to avoid redundancies. And then I can see now that on my database, I do have my types that are not, elements that are categorical, they are numeric, but there's still the new variable that I created that it's category. So I will map that category into numbers again, and the order of the numbers, they matter, because you saw when I did the cross table that as I was going up into the variable, I was decreasing the accepted. So I will make that to be from 0 to 6 because I have 7 different intervals. So I will be increasing the value of the variable, and then my model will be able to catch that specific point. That's it. So, well, as an exercise, since you are going to have access to this code and the database also later, why not try to do the same with variables 3 and 4? Because if you take a look, variables 3 and 4, well, they may be as interesting as variable 2. So I would let this as an exercise, not necessarily I'm going to be doing this right now. And here comes the point about developing a machine learning model. Now, it's of course always important to really understand and split your data set into training and testing set. Of course, when you have more data, my recommendation usually is to get the training set, a testing set, and a validation set. And the reason is I will train the model in just one particular point. Remember that nice function that Julia showed in the beginning. So I will make the model learn out of the training, and then I will compare what I have learned during the training with the test. So if my model is good, I will be able to replicate the results into the test and check also for the stability. What the stability means in this case? It means that your model is capable of generalization. And why this is so important? Because it's all beautiful when I'm in my computer playing with my code. I can do whatever I want. However, out there in the real life, I'm gonna get data that it's unseen by my model. And if my model is not able to generalize, I will never be able to get a very nice model when we are up here into the deployment, when we are into production. So my model should be able to really distinguish unseen data in a very good way. That's why we do this split into the data, so you can ensure that your model is not as good just because you have pushed it and overfitted it. Your model is good because you have good attributes, you are a good programmer, and then you are able to create a model that can really generalize with type. Sorry, there's a type over here. So I divide my database. I take half of it for training, half for testing size. I set a random state that it's the fact that when I do this split in this case, it's random. So when I set this random state, it means that whenever I use this number, I'm going to have exactly the same split. So you are able to reproduce this code in your computer, using exactly and to have exactly the same results that I'm gonna show. So that is quite easy. And here is the point that you can see, training the model. Actually, that's it. Is this component over here? I have trained in my model. That's why in the beginning, and I love that, because sometimes the training the model can be as quick as I did, but then you can see that, well, you may actually take a lot of time in the preparation of the data. I'm emphasizing this because this is what you are going to do in whatever business that you are. Even if you work for a company as Experian, or if you open your own company, you are going to be doing something like that. You need to get through that steps, and then you're going to see that, well, maybe 70% of your time, you're going to be doing other things that are not the model itself. Then you go to the modeling component. So coming back to our code, I have trained a generalized linear model with the family that is the binomial. That means the logistic regression in this case. And then I applied the fit to my training set. Now, unfortunately, cannot enter here. I would love to spend more time with you explaining how to judge that kind of results. How could we really do a nice interpretation out of it? So I will have to jump this to head into something more practical. That it's how do I can evaluate my model and not just the attributes itself over here. Well, there are two components that they are the standards in the industry. That it's about a component that we say ALC, that it's the area under the curve, and the Gini. So they are very interesting measures to understand if your model had a good fit. Now, those numbers, they may vary up to 1, meaning that 1, you have a perfect fit. And then if you get, of course, lower than 0.5 in ALC, it means that it's better to just toss a coin. And the Gini also can be as lower as 0 in this case. So you can see that we have a very good number. We got almost 1 for the ALC, and almost 1, 0.9, sorry, for the Gini, which they are very good numbers. And here you can see that I'm doing this for the training and for the testing set. Why? Remember that I told you that we need to observe if we can generalize our model. So if I have trained my model using this, so I need to apply my model in the testing set and see how close I am to the training. So you can see that, well, I am close enough, might not be that good, because actually I am with a 10%, almost 10% difference. Is that acceptable? Is that not acceptable? It depends on your use case. I would say that this model can be improved in terms of instability. For me, it might be a little bit too much, 10% for my case. So how do you improve your model? Well, remember, there are some variables that eventually we have to work a little bit more. We could get other variables to be treated, something that we call feature engineering, and then eventually we can have a more stable model. There is a trade-off. Sometimes you may prefer a more stable model rather than the best possible model, because stability sometimes is preferable in relation to performance. Of course, you need to get the best of the two. However, sometimes you need to make a choice. There is no free lunch in this case. Now, there are other ways that you can interpret your model. What is the outcome of a model? Actually, when you work with a logistic regression, that it's our case, it's a range that goes from 0 to 1, that you can interpret that range as a probability of that outcome. So as closer as you are to 1, more you can be confident to accept that request for a credit card. And then as you are close to 0, you can reject that specific application. Now, you can play with these numbers, because what if I have 0.7? What if I have 0.6? There are several things that you need to work with. So there is some points that you can understand what is your optimal point. So where do you get the best accuracy possible of your model when you establish the point that I say, well, above on a specific level, I will do some acceptance, and below I will reject. Of course, this is not just evaluated by this optimal number that you are going to decide yes or no, accept or reject. There are many other variables. So, for example, how much cost to the financial institution one right acceptance, and how much it cost a wrong acceptance or a rejection. So there are several components that they need to be included within this analysis. So this is very superficial, just to let you know that this exists. And then once you are there, you can understand exactly how is the relationship. So on this chart, you can see that as you grow the blue line, you decrease the red line. And the blue line is the true positive rate. So it's as much as I'm concentrating my data and I'm getting the right numbers. And as I grow my true positives, of course, I need to decrease my false positive rate, because I will be trusting my model more and more. And then I will adjust my model to the cutoff point, that is specifically 0.425. And then I can see that, well, I have lots of acceptances in this case. So my model, it's quite interesting in the results. But how do I really evaluate my model? So there is something that it's called confusion matrix. And the confusion matrix is quite interesting because it's nothing more than just a cross table in between your predicted values, so the outcomes of your model, and the real values that you get, the actual values. And then you can really understand how much of the positive ones you have you did it right, how much of the negative ones you have predicted right, and then eventually the difference of the ones that you should have done then right, but you get wrong, and vice versa. So the output of a confusion matrix would be something like this. So you can see that, well, following this rule on the predicted value, well, I have predicted in a positive way 135 of the positive ones. And I have missed, so I have classified in a wrong way, people that they were good, but my model told that they were bad. I have classified 18. So here I'm losing business. On the other hand, I'm also might be losing business here because I have classified right 168 of the ones that they were rejected, so good, but I also rejected 24 people that they were, I accepted, 24 people that they were bad people for the company in this case. So this is the kind of business evaluation that you are going to have. In the end of the day, all of it, you can get the accuracy. So how much of my true positive and how much of my true negative I'm really getting. So my model, it's getting 84% right of my good ones and 84.81% right of my true negative ones. So there is room for improvement. I mean, it's very hard to get a model that will get 100%. So this is not even realistic, but you can push as much as you can, as much your ability to program and to know the business or how much experienced you are. But I would say those, depending on the application, those numbers that they are quite reasonable. But for sure, given the fact that we didn't that much of data exploration and engineering, given the time that we have for today, for sure, there is a lot of room to improve. And how do you are going to start actually this kind of coding? So my recommendation is, whenever you are looking at a code and you really don't understand what that piece of code is doing, try to isolate that. So for example, what I'm doing here, well, I don't know, here's a block of code, maybe I do not understand. You can simply copy that specific piece, then you copy that somewhere else, and then you try to run and check what you get. So this is just a practical recommendation for you to start. And I would be happy to talk a little bit more, but I think we are almost on time. So I would like to open the room for any questions or comments that you might have. But this is just an example what people like myself, like Giulio, that we do on our daily basis as a data scientist in Experian. Of course, this is just just a little bit of the full iceberg. But it's a nice example for you to check and see how can we use data for good. Because in the end of the day, as we do very good models, we can help society, we can really help lenders and the people that are trying to achieve their dreams using that specific amount of money, so we can help the whole society. And it's our responsibility to develop such kind of models in a way that they are responsible, they are transparent to everybody. So thank you very much again for your time. And we are open for questions. So whenever, whatever you want to know, and really happy to be with you. Thank you very much.
Great, thanks for that, Leandro. So I've just brought back Giulio and Paul to sort of wrap up the content, and then we'll open up into the Q&A.
Yep. I can see that there is a question there that it's mentioning at the beginning. You said you hold so much billions of data. So I think that one when Paul was commenting around Experian. So what are your data sources? So I don't know, Paul, if you want to take that one.
Yeah, sure. So there's again multiple sources of data. I think from a bureau perspective in particular, we talk to all the credit providers across the world. Those credit providers are recipients of our intelligence and scores that you've seen them build here today. That goes back to them, but we are also required to collect data from multiple credit providers in order to collate that information. So there's that sort of component. The other initiatives that we're working on, particularly from the data for good perspective, is that we are looking at seeing how we can, with consent, very, very important, with consent, engage with consumers and businesses across the world to take them down a journey of helping them meet their specific commercial needs and us understanding them. And during that journey, they are willingly sharing data with us, which we can then consolidate and build into these models as well. So there is a formal financial services offering in terms of collecting the data, but there's also a voluntary journey where people share data to understand and grow what those their specific needs are. And we collect and collate that data very securely, safely, and within all regulations across the world. And then when we build the science behind it, like Giulio and Leandro have shown you, is that we don't go and say specific individuals, we build a collective overall insights. And so that's where we get our data sources from. So we have many, many data sources, and Leandro talked about the engineering side of it, is the collation of data, putting to databases and managing it is really quite important as well. So hopefully, Jay, that answers your question.
Yeah. And I mean, maybe I can say something regarding some other questions that are referring to how you became a data scientist and what's the difference between data scientist and data engineering and data modeler. I mean, there are a lot of names. So first of all, how I started, actually, as I said, I come from a very technical background in mathematics. But actually, I was studying, application of maths in quantum computing, into quantum field theory, particles. And what I want to encourage people is to really think big and think wide, because AI and machine learning, really, you can make it from a lot of angles and a lot of backgrounds. It can come from engineering, can come from maths and physics, but also you may come from other backgrounds, because, for example, we have people that are coming from marketing and philosophy, and so really not too technical. They of course studied some coding, but in the end they were not so skilled in technical part, but they are adding a lot of value, for example, to explain in a very easy words what AI and machine learning is. So really be open, because it doesn't depend just on your background. You don't need to study mandatorily data science at the university to be a data scientist. And then about the differences in career, really, I mean, you saw from Paul's presentation, Experian is a huge company. So there are really around 18,000 people, and there are a number of names of data scientists, senior data scientists, data engineering, data modelers, and so on. So yes, there are a lot of differences actually. Usually when we speak about data scientists, this is someone that has a mix of skills that comes from okay, coding, that of course is relevant, but also in terms of marketing, in terms of consultancy. So how to really face a challenge, understand clearly what are the requirements, set up what are the deliverables of a project. So this is something much wider than pure coding. When we refer to pure coding, usually we speak about data modelers, because those are the people focused on purely modeling. And when we speak about data engineers, you heard from Leandro, modeling is a continuous process. So it's not about just make a model, deploy, and that's all. No, it's about continuous training and continuous learning. So this piece of automation, to take data, to retransfer to the training part, to put into the deployment and so on, this is the work of a data engineer, because he's the one that is really engineering the full process and the full framework. So usually this is really purely technical background. But thank
Giulio,
you for all this.
Yeah, if allow me to complement one important topic. So you have the data engineers, like you said, but on this salad or fruit salad of names, you can get machine learning engineers, you can have BI analysts, you can have data analysts, you can have the data engineers. The main difference is it depends also on how big is the company that you're working for. So usually, if the company is it's big, you are going to have this kind of a separation, because you are going to have some specific departments that they take care of extracting the data, and then there is going to be some people that are going to be preparing that data for modeling, and then eventually you get somebody just to do the data modeling component. Then you have the machine learning engineer, that it's the one designing machine learning models. And by designing, I mean not picking up established components of libraries from R or from Python, but actually they are designing the functions themselves and eventually packing them into a new library. Of course, the data scientist needs also to know how to do that, because eventually on that wheel of solving the problem, this is so important. However, if you work for a small business or if you work for a fintech, it's very likely that you are going to have to do everything. So you're going to be the data engineer, the data analyst, the data modeler, the data scientist, and etc. So that's why this kind of different job titles, they are going to be related to the specific size of the company. One good way to learn the difference between them, if you go to LinkedIn and then you do some job search using these keywords as the name of the functions, you start to have an understanding on what the companies are asking for. So you start also to understand better what are the differences between them, and eventually one field that you might be with more affinity to work with. And I'm using this just because there is a question. Actually, there are a couple of good questions. There one's from Charlotte around the confusion matrix. So before getting into there, Charlotte, I would just address the one from Space Cole, where she asking about the Python and the R debate. Which language is preferred or has more possibilities when working with data? So I have seen everything, to be honest. And Julio can, please don't let me lie over here. But inside the company, we have people with both backgrounds. Sometimes we go to clients and then clients say, well, you are showing this in Python, but here I'm working only on R. And by clients, I'm talking about some of the largest European banks. And then some of the other largest European banks, they also work with Python. And some of them, they work with both. So actually, you are going to have possibilities on both sides. One good way to take the decision, because sometimes it's hard to get to study the two languages at the same time. So if you have a preferred field, or if you have, for example, more affinity to go to financial services, and here's just to pick up one example. So you may notice from the job postings that they start to ask more about Python, and then you start then dedicating your time in there. If you go for some institutions that eventually they might be a little bit more academical, or people that they have a little bit more of an academical background, well, sometimes they may prefer R depending on the kind of utilization. There is no thumb rules for that, specifically speaking, but this is a way that may guide you to take a decision on prioritize which one you would have to learn. If you will observe, when you really have to work with big data sets, well, to be honest, here Python may have its preference, because you do have some frameworks like PySpark, for example, that they integrate very well with cloud platforms, and companies, they may go towards this. That was a thumb rule, but then we got Microsoft acquiring R Revolution, and then R has become a very large component of the Microsoft Azure suite. And then you can also have R to work with some data sets within the cloud. So this is the way that you do the distinguish, is trying to understand a little bit more from the industry that you are planning to work on, and what is usually for beginners. I mean, wow, it's the first time that I'm talking about coding or that I'm seeing coding. Usually R has a more simple syntax. It's a little bit easier for you to start understanding the concept. And then, but that is the point. Languages, as I said, they are just tools. So once you get the logic behind one, is not that difficult to migrate. And then when I met Julio, I saw Julio coding first at R, and then for him to switch to Python, I mean, it was a matter of weeks, to be honest, right, Julio? So it's about the tool that you are gonna work with. And sorry to talk too much, but just to come back to the point from Charlotte, the data that you get to use into the confusion matrix. So once you do the predictions of your model, so you have your training data, you have trained your model, you use a function that it's called predict. So you are going to assign to every single record of your database what is the expected outcome of that model. And then you do a cross table of that outcomes of the model with the expected values. That was your target. When you do this cross table from the model's outcomes and the expected value, you can have that confusion matrix. And then you do this for the training and for the testing, and then you can get out those metrics that I mentioned to evaluate your model. So I will shut up, otherwise I talk too much, but that was the point from your question.
Yeah. And I think that we have two other questions. One is for Paul, that is from PJ, that is saying, Paul, how do you get into the data? So do you want to say something about this?
Yeah, sure. And before I carry on, you might have noticed that it all went dark here. I'm sitting in South Africa where we have what's called load shedding, which is our government's control of electricity supply, and it's scheduled, and so suddenly the power just goes off. So I'm sitting here with these fake lights. So my apologies for that. I was also completely left in the dark when Leandro starts coding and Julio starts talking about these things. I mean, you are quite blessed to have these two guys talking to you, because they are really, really skilled at what they're going on about. So if you want to get into data, I think they just have the passion for it. I mean, I think Julio and Leandro both display the qualities of having passion for something which the majority of the world don't understand. And there's so many different courses. Have a look at Girls First Code as well. They really bring an incredible accessibility to teaching yourself the technology and the back end of it. But luckily, Leandro said just now, data is not just about the tech and the coding side. It's really about understanding what are the business problems that you're trying to solve out there. What are the source of the information that you've got? What can you do with that data to make it work and tell the stories that you needed to tell? Or tell the stories you don't think it's going to tell, but they end up telling themselves. It's also quite a nice one as well. So getting into the data side is getting passionate about it, learning about it, self-learning, experimenting. I mean, there's so many times when people are in this space that they don't get the answers, but they carry on regardless and make it happen. There's also a question about, I think there was earlier about the internships and leading into that. So going into the data side, I'm sure Leandro and Julia will give you the expertise. I'm not a data scientist at all. I'm more on the business side and the innovation and the thinking and the strategy. But if it wasn't for data science, it wasn't for data, we wouldn't get anything achieved. So for me, a Python is a snake and R is some letter in the alphabet. I know I say that blasely and innocently, but we've got talented data scientists here in Africa as well. They work very closely with our EMEA team. We are continually rolling out products across the world. We don't just limit to certain geographies, so we work like that. So how do you get into data? Study, experiment, learn, engage with communities, talk to people, get a CV built out, get into internships, get a job going, work with startups, work with friends, work with corporates, and experiment a bit, grow your own career into these sort of space. The other question, I think what was for me, Julia, was?
Yeah, the other one is about does Experian do summer internships? So I'm sure here you can say many stuff.
Yeah, so I can talk about it all the time. In actual fact, one of the reasons we're here is that Experian has entered into a strategic partnership with Girls First Code, if I've got the name right. And we've actually signed up 4 interns through a EMEA space where we are going to be working with them for 9 months. Both Julia and I are working very closely with them. We are putting them into very difficult projects. We're giving them exposure to both the business side, the client side, but also the technology side, the data scientist side. And they're coming on board with an eagerness to learn, but also for us to show them the real world. I mean, Leandro was always talking about the real world out there. It's not glamorous all the time. There's hard work. It's not just about showing a graph of Gini coefficients which reach 1. There's a lot of graph that you've got to roll up your sleeves and get stuck into making this work. And so yes, Experian does offer summer internships. We do it through partnerships like with Girls First Code. Reach out to us, get hold of us through the different initiatives that we've got there. We've got some people on the call here as well who look after the HR side of things. But the reality is an organization our size is always looking for talent, not only for our own good, but also for yours as well, to be able to teach and to learn and to encourage and to grow. And you can build careers working with Experian across multiple dimensions. We've talked to be a global organization. We're not static. The last thing we do is traditional boring stuff. We're always innovating, experimenting, and building new products. We need data scientists, we need data engineers, and all these different job descriptions. So yeah, be brave, put your hand up, contact us, volunteer. Internships can lead to full-time jobs. But like I said, Rebecca's also on this call, has facilitated with our head of HR, Rona. We're in strategic partnership with Girls First Code. We've got 4 interns that are working for us now. And I'd love to hear, I think, 6 to 9 months from now, because they're going to be completely different people because of the exposure what Experian can give.
Yeah, and and something to encourage you. I entered Experian 10 years ago from an internship program, and here I am. So there is a really nice space for you to build a career in this company. So, I mean, it's not by coincidence that it has been a decade that I'm here. So, and here I'm doing a little bit of publicity for Experian. It's a really nice place to work. It is. Well, I have been 10 years, 2 different continents. So, as Paul said, keep looking for opportunities. They are everywhere around the world. You saw from the beginning when Paul was mentioning that we are worldwide. So for sure, there will be an opportunity quite soon, especially because this career of data science, I would not even call this just a data science. I would say whatever you work with data, because it's not just about data science. You need, and we need, supporting jobs or roles that they are as important as ours. So there is no job that is more important than the data scientist itself. So, for example, how Julio and myself, for example, we would live without people like Paul, without people like they work with us, that they manage the products, they manage the programs that we run, they manage the projects that we run. And those projects and the programs, they are around data. So you can also get an understanding of the data. Maybe you find yourself not necessarily so interested in coding, or because you didn't have the time and etc. But there is all the other functions that they work together with the data universe, that they are as important as the data science one. So there are several possibilities that you can jump into a data career, and they are equally important. And the demand is as high as the demand for data scientists.
Yeah. And I see another couple of questions actually. So the first one is how much time do I need if I come from a complete different background to change my career and start in data, as Leandro was saying. And again, I can share my story. So when I started my career, I started actually in a bank as a trader. So I was working as a quant in a trading desk. So again, I was working with the pricing of derivatives. Okay, so that's again, it's stochastic differential equations and again, maths and those kind of stuff. And basically, I received a call from Experian. So I was very lucky, I would say, that they called me to offer me a position. And so I switch literally daily. So what's the point I would like to reinforce? You say you're a research in biology, so that's wow. I mean, that's a super job. For sure, you have a very strong background, you have a very logic mindset, you have culture, you are inquisitive. So those kind of skills are the one that will allow you to do whatever you like in your life, and that will help you to become a data scientist. Really, if you put the right effort in a few months, because you can start to train yourself with coding. You can do really through also internet. It's full of books, coding sites, and so on. So it's something that you really can switch easily. And believe me that me, Leandro, Paul, we really learn every day. So it's a continuous learning. That's the probably the thing that I mostly like of my job. I never stop to learn. And I live for this. I mean, I love that my job is not the same of 1 week ago and 2 weeks ago and 3 weeks ago, because you are on the cutting edge of the technology, and every day there is something new. You need to study, you need to spend your time on that. So there is always time to switch, and it will not take too much time. It's just a point of passion and how much time you want to spend to learn something more. And also about a recommendation for data science, as I was saying, there is a universe on the web. There are public sites where you can code. There are university that are offering also free courses. I remind myself, I spent like I think 6 months on Coursera. Coursera is a site from university that is including other guys where you can literally code on that, and it costs really something quite ridiculous that will allow anyone to make it. But there are also free sites, and I will just suggest you also to look for some books, if you like, really. It's something that you can find on the web. There are hundreds of books. If you write simply Introduction to Statistical Learning or Introduction to Data Science, that those will come with a lot of results on Google, and you can download a PDF and take it and start to have a look. And really, that's an incredible journey. Really, believe me that it will be something that will take a lot of time to you, but you will learn really every day. It's a great job, and I really encourage you, as Leandro was saying and Paul was saying, I encourage you to try to send your CV to Experian, because really I have to say that I learned a lot. I'm enjoying a lot. And I traveled a lot. I met a lot of good guys, really brilliant people. So it's really a great place where to start and to continue your career. So good luck for that.
Yeah, there is a particular book that you can find with free distribution by the editor into the web, that it's called Elements of Statistical Learning. It's a brilliant book available for free in PDF, that you have essentially several different types of data techniques and the modeling techniques. So if you're curious, and if you are a kind of a book lover, like to study by books, not necessarily just by video, it's a very good one that I would recommend.
I just want to add to that as well. I think I'm probably older than Julia and Leandro combined. And when I started out my career, we didn't even have internet or mobile phones or anything like that. So an email address was not even we heard of. I mean, I got my degree actually going to a library and studying in a library. So that's always been a way to show that you've got to be also careful that sometimes it can be too easy to access information. So I'd highly recommend that you find your passion and specialize in that and grow from that sort of perspective. But like Julia and Leandro said, I mean, we here at Experian every single day get thrown different challenges from our customers. We throw different challenges through what's happening in the world around us every single moment, but also amongst ourselves. And so we encourage you to be in a continuous learning curve about this all at the same time, and get stuck in and build things. I know I'm interrupting because the next question is what sort of kit, and we'll leave that to Leandro to answer because he'll know.
No problem. No, and well, actually, if you are in the beginning, you don't need any fancy setup really to start learning the data science. So I mean, a simple notebooks or personal computers that you have at home with 4 gigabytes of RAM, and I would say at least 200 gigabytes or 250 gigabytes of storage would be more than enough. We know that nowadays, usually this kind of configuration, it's not that so difficult to find. So that will be more than enough, because despite we talk here really about big data, about different things. So when you are really learning, and the most important component is for you to get all the logic behind what you are doing, you don't need so much fancy equipment to get your job done. And if you need a little bit more, or if you don't have any kind of a setup, even with a more simple configuration, you can code online. So there are platforms like, for example, Google Colab, that you can run on the cloud, so it doesn't require much from your computer. You can use Jupyter notebooks there to run Python code, for example. So there are alternatives as well if you don't have access to a good setup. But if you have the internet connection, then you can use those kind of tools to get your learning going.
So it seems that don't know if there are some additional question or something, Eileen, if you want to say something.
Yeah, thanks so much, you three, for answering all the questions. I think there was one more thing, that there are more Code First Girls classes with Experian in January. I think you'll have one in Python and SQL and data, so stay tuned for that. And I think just to close up and just to wrap up, I'm going to ask three of you, like, what's the one thing you want the audience to take away from today?
Honestly,
I go first.
Yeah.
Go first, Paul.
I'll go first. Yeah, we're doing the same order we presented. I think at the end of the day, what's important is that there's data is something that, first of all, belongs to everybody. You should be able to trust organizations with that data. You should be able to know that the data is being used wisely to make an impact, a very positive impact. And I do believe that from a business perspective, you can trust Experian with that, because we fundamentally believe in the power of data and the data for good. From a personal perspective, from yourselves who are in the audience, I encourage you, if this is something that you're passionate about and want to pursue, don't hesitate. Knuckle down and do it. And reach out to us and contact us to help you with careers, help you with ideas and understanding and all those sort of things. Life is busy, there's no doubt about it, but we also want to make a difference and an impact in the lives of people around us. So we are exponentially going to change the world, make it a better place to live through the power of data, and we'd love to journey with you on that one. Thanks.
That's great, Paul.
Wow.
Thank you.
Wow, Paul. Okay, so now it's a hard job for me, but yeah, I want to say that I do believe that data and AI are enabler to make your dream come true. So try to imagine and being inquisitive how you can really land your dream through data and AI and technology. We live in one of the most exciting century of whole history of life. You can do a lot of stuff that looks really unbelievable. And the point is how, again, to use those data to make something good for our planet, how we can reduce differences between people, how we can reduce pollution, how we can help people to realize their dreams. We can do that, and really, I strongly encourage you to think big, because really, today we can do whatever we want with data and technology. And thank you.
Great. Thank you so much. And Leandro, what's your take?
yes. Well, my take is you could see that doing coding, it's possible. You can get several examples out there and be able to reproduce them, to remember them by heart. What really makes the difference on what it's a great data the scientist or a data modeler or whatever the job title, it's your critical thinking. So if you pick up the sentences that Paul said, that Julio said, and that I said, it's about understanding the environment that you live in, the industry that you work for, the company that you are in. And then if you get to understand everything very well and you have this critical thinking, nobody it's going to beat you. You are going to be unbeatable. You are going to be the professional and the kind of people that it's going to make the difference into the world. So I mean, you can learn to code. That it's not the difficult part. I do interview with several candidates they are really, really good in coding. What it's make the difference between them, it's the way that they use what we have here inside our schools, that it's our brain. So thinking about that, thinking about how you could change the world for good, how could you leverage all those assets that they are out there, and then you're, well, as they say in the movie, to the infinite and beyond. That is the message.
Amazing. Well, yeah, thank you all so much for joining us, to the audience for joining us, and to our three gentlemen here for sharing with us their journey and sharing the content. But thank you all so much again for your time. We look forward to seeing everyone again in January for the other courses that Experian is going to host with us. So have a great evening, everyone, and take care. Thank you all very much. I'm going to end broadcast.
Thank
Bye.
you. Thank you.
Ciao.
Bye-bye. Bye-bye.
Bye.